So, hi, good morning. I am Bruno, and I would like to thank you also for being present. And now I'll start by presenting one of the research projects in which I have been involved. I'll start by providing you with some context. Emotions play a leading role in our lives. They guide us in our daily lives' decision-making. For instance, think about the feeling we get when we consider going home late at night through a dark and unknown street late at night. So this might not sound good, this idea. This not good is in fact the influence of an affective heuristic in our decision-making processes. Additionally, memories are mediated by emotions. Numerous studies have shown that the most vivid autobiographical memories tend to be those of emotional events, which are likely to be recalled more often and with more clarity and detail than those of neutral events. Emotions, of course, play also other roles in our behavior.
To be an empathy test, capillary dilation of the so-called blush response, fluctuation of the pupil, involuntary dilation of the iris.
Emotions are indeed part of what makes us human. This clip came from Ridley Scott's Blade Runner, in which emotions are used as part of a test that is used to distinguish between human beings and androids. But perhaps I should start this presentation by defining emotions, or attempting to, which is an ongoing discussion among scholars. As Murphy states, emotions are anything but easily bounded and have significant individual variation between individuals in expression and experience. This means that not everyone understands or experiences emotions common like love or hate the same way. Lisa Barrett, nonetheless, provides an interesting definition of emotions, stating that they are momentary evaluations of one's core affect. Core affect, in turn, is the ever-changing state that surfaces to conscience whenever it's needed to be categorized, like a snapshot of our core affect. Robert Plutchik, on the other hand, presents an evolutionary perspective, more linked to biology, and defines emotions as being feedback processes that induce action in order to restore an individual to a pre-existing state of comparative rest and equilibrium. But these are just examples of definitions, as there are many more to be found on the literature. There are many examples of emotions being used in computer science research projects. For instance, in eHealth, Madeira and colleagues have implemented a mobile application for supporting people with stuttering disorder. Whenever a stuttering disorder occurs, their application allows its users to register a number of emotions being among them. But perhaps the greatest example of the interest in emotions is the founding of affective computing, which is a field that, as stated by its founders, studies computation that relates to, arises from, or influences emotions. There are two prevalent theories of emotion, the discrete and the dimensional theory. The discrete theory assumes that there are a small number of independent core emotions hardwired into our brains. They are biologically determined responses whose expression and recognition is fundamentally the same for all individuals, regardless of ethnic and cultural differences. The dimensional theory, on the other hand, also assumes that there exists an independence in emotions, although it is verified along the axis of orthogonal affective spaces. So emotions are in fact experiences composed of a variable number of orthogonal dimensions and can be pinpointed in affective spaces. Each theory has its own underlying model of emotion. Whereas the discrete theory proposes a number of independent emotions, like joy, trust, or fear, the dimensional theory assumes the existence of affective dimensions, the most common being valence and the degree of pleasantness or unpleasantness, and the arousal, the degree of physical activation. But the question still remains, how can we assess someone's emotional state? Psychologists usually resort to pen and paper questionnaires, generally administered after an emotional experience has taken place. However, the memory of emotional experiences has been proved to vary greatly with time, tending towards an oversimplification. Therefore, it results that immediate in situ measurements of affect are potentially more accurate than retrospective assessments. Moreover, for what concerns HCI, these extensive and time-consuming questionnaires are not easily integrated into functional user interfaces. Here are some examples of assessment tools. The first is the self-assessment mannequin, which is a non-verbal pictorial assessment technique. To use it, subjects have to select the image on each strip that best matches their affective experience. The first strip stands for valence, positive and negative, the second for arousal, calm or very excited, and the third for dominance, which means submissive versus dominant. This is the effect grid, which is a single-item scale that was developed as a quick means of assessing effect along the dimensions of valence and arousal. To use it, subjects place a single mark somewhere on the grid in accordance with their perceived current affective state. This last one is the PANAS and negative affect schedule, which is a 20-item self-report measure of effect. Subjects have to indicate on each item the extent to which they are feeling in that current way, in that specific way, using a 1 to 5 scale. These are just examples of traditional pen and paper questionnaires which are not easily integrated into functional user interfaces, as they have some relatively lengthy question instructions and they require more than a superficial understanding of the concepts involved. So our challenge was to develop a tool that would be amenable to seamless integration into user interfaces while being simple, pleasant, and quick to use. And this is our proposal on the right, which is the Circumplex Affective Assessment Tool. It is an assessment tool which was based on Robert Plutchik's circumplex model of human emotions, which you can see on the left. Both the emotion words and the colors are the same on both depictions, although the order on the assessment tool on the CAAT has been reversed. This was because we needed a selectable node for emotional indifference, the nothing central node. In Plutchik's model, there is rather an implicit no-emotion periphery. The tool only has one short instruction. You select one or two emotions. To use it, users are then asked to choose the one or two emotions that best describe what they are currently feeling. This is our tool's score system. The CAAT has two different outputs. A discrete output that corresponds to the selection of emotion words, and a dimensional output which corresponds to two numerical scores measured along the dimensions of valence and arousal. Each emotion word has its own pair of valence and arousal values. If users just select one emotion word, the resulting score will be those of the selected emotion. On the other hand, if two emotion words are selected, the resulting score will be the average of the selected emotion scores. Validation is, of course, a very important aspect of creating new tools. We have then evaluated the CAAT on two types of validity. The first is construct validity, which is the degree to which a test measures what is supposed to be measured. In our case, that the CAAT measures emotions. The other is temporal reliability, which refers to the consistency of results over time. This means that for the very same conditions, the CAAT should perform consistently. This is the design of our study. We have developed a website serving an online questionnaire that presented the same 12 affective stimuli to participants. The study had 3 sessions. Session 1 and 2 were separated by an interval of time of minimum of 30 seconds, and sessions 1 and 3 were separated by an interval of time of a minimum 7 days. On each session, we have recorded participant responses to each stimulus, as well as the time of those responses. Regarding the 12 stimuli, we have used the GAPAD database of normatively rated emotion eliciting pictures. By using such a database, we add to the study's criterion validity, since we have additional control over the emotions that we elicit in people. On the GAPAD, images are classified into 3 classes: the positive, the neutral, and the negative. These are the positive stimuli we have used in our study. On each image, you can see the mean valence and arousal scores. There are other metrics that are available for checking on the database, but I'll just present you the means, valence, and arousal. These are the neutral stimuli, and these the negative. if you'll allow me. Moving on. These are the demographics of our participants. 133 participants have responded to sessions 1 and 2. Out of these, 106 have also responded to session 3. The sample is quite heterogeneous, particularly with participants mainly coming from Portugal, but also the United States and Spain, and roughly being half female and half male. But we have also had some participants from Guatemala, Canada, and other countries. I'll now start presenting and discussing the results of our study. Regarding temporal reliability, that is the stability of the tool, these are the correlation coefficients of the 3 sessions results. We have done this test to see if the CAAT scores correlate with themselves for evaluations, readings taken at different moments in time. The different length between the intervals of time that separates our sessions allows us to have a broader perspective on the CAAT's temporal stability. As it can be seen, in all cases, correlations are consistently strong and statistically significant. These results are proof of the CAAT's adequate temporal reliability. That is, the CAAT is stable and it can be expected to produce consistently. Since the GAPAD database features the mean valence and arousal scores for each stimuli, we have also computed the correlation between them and the mean CAAT valence and arousal for each of the 12 stimuli. This calculus gives us a sense of the agreement that exists between the CAAT scores and those of the GAPAD stimuli. The strong correlations for both valence and arousal scores indicates that there is a significant agreement between the CAAT and the GAPAD effect assessment method. We were also interested in seeing if the CAAT produces different scores for stimuli belonging to each of the 3 GAPAD classes. To verify if this is true, we have conducted a one-way between subjects in ANOVA, using valence and arousal scores, but this time just for session 1, followed by a post-hoc test to assess which classes does the CAAT in fact manage to differentiate. Results indicate that there is a significant difference between valence and arousal scores among the 3 classes. These are the results of the ANOVA. Here we can see the mean CAAT scores for each of the 3 classes. The post-hoc analysis revealed that the CAAT valence scores managed to distinguish between stimuli belonging to the negative, neutral, and positive, although the valence arousal score manages to distinguish the neutral from the other 2. This distinction evidences the CAAT's construct validity, that is, the CAAT does indeed measure emotions. Regarding the quickness of use, our study reveals a learning curve, with the average initial time for the first contact with the tool being around 28 seconds and progressing towards 15 seconds by the end of session 1. The red vertical bars indicate the intervals of time between sessions. In session 2, which took place almost immediately after the session 1, these results are very near a 7-second asymptote. In session 3, which took place at least 1 week after session 1, results start a little lower, that is, the tool is learnable, and they again progress, but more rapidly, towards the same 7-second asymptote. Taking into account the results I have just presented, this presentation's take-home message would be that the CAAT is an adequately reliable tool for emotional reaction assessment. It is fast, stable, and studies attest its construct validity. Therefore, the CAAT can be considered an option if you find yourselves in need of a tool for emotion assessment to integrate in user interfaces. Finally, if you are curious about the tool and its validation process, please read the published papers or send me an email. I'm always happy to answer. You can also download the tool as a ready-to-use web widget from the address at the middle. And with this, I conclude my presentation. Thank you for your attention. If you have any questions, I'll be happy to answer them.
Okay, do you have any questions?
Thank Thank you. Hi, Celine the Tulip from UNC Charlotte. This was a nice talk and visually beautiful too. I'm interested in what your intuition is as to why the correlations that you're seeing across the different studies you did are so much lower. Not that they're really low for arousal, and the sort of follow-on to that is, did you consider biometrically measuring your participants' arousal to see how that correlated with their reported arousal?
Well, regarding the first question between the lower arousal correlation scores, people, when they made a selection on the tool, they are primarily driven by valence. That is the conclusion that I have been extracted. That is the same to say that people usually select emotions that are similar in valence and only then arousal. There is also a significant correlation, and please remember that these are emotional values, so they are by nature very volatile. So that would be the answer for the first question. It's the primary driving force that drives people to make a selection on the CAAT. And for the second question, I thought about that, but I was mainly interested in self-assessment tools, not rather automatic detection, not biometric. And these were tests made on the wild. So we just published using a snowball approach. We just sent emails to everyone and did not felt that would be easy to collect images that allowed us to analyze some biometric values. So we did not do that correlation. That would be cross-correlation, right? It's a convergent correlation or validity, but we have not done that. We have validated the other way. Thank you for your question.
Okay, I have a question for you. So you mentioned that the goal of the tool is, the widget is to make it easy for users to report emotional state. So I'm wondering whether you have any observations about how, in your study, how the participants learn the widget and how easy they felt to use the widget.
Your question is about the time. Sorry. Could you please repeat?
Do you observe any difficulty for participants to learn how to use the widget?
No difficulties have been reported, although in the questionnaire we have also had a free text box to allow people to provide us some different feedback. Some people asked for different emotions rather than the ones that are displayed on the tool. We didn't do this because the possibilities for providing emotion words is vast. We have over 1,000 emotions, words for defining emotions. There is a lot of ambiguity. But people can select two emotions. So somehow this ambiguity is divided, is sorted out that way. But the main difficulties were in fact just that comment that we detected. People wanted more emotions, or they wanted the exact emotion word they had in their minds.
Okay, thanks.